Let's work on the problem 5.3.28, okay? So we need to find Norton or the Thevenin for this guy. So we need to take this guy out and find the VTH. So when we do this, we need to take out, find the VTH plus minus. Since we made this as an open circuit, there's no current going through here, 4K. So it's not fair, or it's not right, I should say, to calculating VTH here is not the correct VTH. Therefore, we're going to take this 4K out as well. And then after we found the VTH, plus minus VTH, and then we're going to calculate RTH, which is VTH over I of n. We need to find I of n. Why? Because we have a dependent voltage source. So we're going to do this, and our load is going to be this 4K and 4K. Now for the Norton circuit, it's going to be IN, and this is RTH. And in here, now we're going to put, this is 4K plus minus V0. This is Norton, this is Thevenin. That's correct. So that's what we're going to do. And because of, again, because of this dependent voltage source, dependent current source, for example, you could have the dependent current source, then we won't be able to find RTH. Therefore, we need to find I of n. So we need to find VTH, and we need to find I of n, and put this or this. It depends on the questions. I'm going to find that out. Okay. So now what? What do you want to do? Super mesh? Okay. Let's do the super mesh. So node analysis. Since this is, is this super mesh? Well, there's no current going around, so it's not really super mesh. We can just do mesh analysis here. We can do node analysis also here. It was an exam. I gave you independent current source at the end, and someone actually named this as I of 2. Don't do that. Not even the same direction. It's opposite direction with the unknown value. That's dumb. So don't do that. So it's going to be this side, and we're going to name as a 3 milli. And for this side, I mean, it's up to you. Which way? Counterclockwise? So same direction. Okay. The mesh 1. We have 6K I of 1 minus 6 plus 2K I of 1 minus 3 milli equals 0. It's just one unknown. So we have 6K plus 2K, 8K I of 1 equals 6 plus 6, which is 12. So I sub 1 is 12 over K, 8 milliamp. So we found I sub 1. Now what? KCL? KCL, you right here? Okay, I'm going to call it A. So KCL at A. Entering I sub X, that's entering. And then we need to be careful, this 3 is going in that direction. It's a 3 milli. And this guy is entering I sub 1. So entering is I sub X, also I sub 1 equals to 3 milli. So now from here, I sub X equals 3 milli minus 12 over 8 milli. That is 24, 12 over 8 milli again. Now what? So we found I sub 1. We found I sub X. Okay. So when we do K, let's do KVL outer loop, then positive 6. So KVL outer loop entering the positive terminal, plus 6K times I sub 1. I sub 1 is 12 over 8 milli. This I sub 1 is in that direction. Watch here. I sub 1 and this KVL is not the same direction, right? For the 6K, the KVL is going in that direction. I sub 1 is opposite direction. So I'm going to put negative here. And then minus 2k I sub x is 12 over 8 plus VTH equals to 0. So calculator, yeah, switch these two? I think so. This one is negative 9, 6 minus 9, and then this guy, minus 3 plus VTH equals to 0. So from here, VTH equals to what? 6. And if we switch these two, and then KVL in the middle, then it's going to be negative 2k I of x. We know I of x. Negative 2k 12 over 8 minus 2k 12 over 8 I of x plus VTH equals to 0. And VTH equals 3 plus 3. Yeah, same thing. And this is, there are two parallel ones, so we can switch that and then do the KVL. We got the same answer. Any question about the finding VTH? Let's do the Norton analysis. I'm going to call it this is A. KCL at A. So I'm going to let current in that direction. KCL at A, then negative 6 minus VA over 6K, that's entering. Second entering is the 3 milli, and then leaving is I of x. So we have one equation, but we have two unknowns. So I'm going to multiply 6K everywhere, negative 6 minus VA plus 18 equals 6K I of x. And then we can do KVL in the note. Then we have plus 6 plus 6K times I sub 1 plus VA equals to 0. We have I sub 1, KCL. We need to have one more. Where? So we know VA equals 2K I sub x. So we also know VA equals 2K I sub x. So if we plug this into here, negative 6, negative 2K I sub x plus 18 equals 6K I sub x. Move this guy to over 8K I sub x. The left-hand side is going to be positive 12 as I sub x equals 12 over 8 milli. So now we have the same. So once we know I sub x, and then you should be able to find the rest. So I'll stop there for the Norton analysis. The rest is going to be the same thing. Right? Once you have I sub x, now you find VA and then do the KVL. And that way we can find the VTH. And we found the VTH as what? 6 volts. Now let's find the I sub n. So now we need to close this. This is I sub n. And all of this calculation is not valid anymore. Okay, I sub n. This is not true anymore. What do we do? Any suggestion? I of x is still the same. But that's a given. We just took it out and then make a short circuit. Super mesh. Okay. Can do super mesh. So the mesh analysis. So it's gonna be I sub 1, I sub 2, and this is I sub n. First of all, mesh 1, we have positive 6 plus 6K I sub 1 plus 2K I sub 1 minus I sub 2 equals 0. Now we need to do the super mesh. Starting from 2K, so negative 2K I sub x, and nothing in here, plus 2K I sub 2 minus I sub 1 equals 0. KCL at A, so we have, this is entering, so entering I sub n, leaving I sub 2 plus 3 milli. So let's simplify this. We have 8K I sub 1 minus 2K I sub 2 equals negative 6. From here, negative 2K I sub 1 plus 2K I sub 2 minus 2k I sub x equals 0. And from here, we don't have any I sub 1, I sub 2, minus, we have one more. $3 million. So we need to have one more here. So that's B. So when we do KCL at B, then entering I sub 2 plus I sub x equals I sub 1. So now let's get rid of I sub x. Let's get rid of I sub x right here. So I'm going to just erase this. And from here we have I sub x equals I sub 1 minus I sub 2. So let's put it up there. Then we have negative 2k I sub 1 plus 2k I sub 2 minus 2k I sub 1 minus I sub 2 equals to 0. Negative 2k, negative 4k I sub 1 plus 4k I sub 2 equals to 0. So now we have two equations and two unknowns. Calculators. I1 equals to negative 1. So I1 is negative 1, I2 is negative 1. Now what? For this guy, so from here, In equals negative 1 plus 2, 3, negative 1 plus 3 milli, 1 milli. So it's a positive 2 milli. So this guy equals 2 milliamp. And VTH is 6, and RTH equals to VTH over I sub n. VTH is 6 over I sub n, 2 milli, so 3K. This is 3K, it's a 3K. So now we need to find the voltage across here. For this guy, we need to do V naught equals 4K over 4K, 4K, 3K, 11K, and times 6 volts. That is 24 over 11 volts. For this guy, I want to find I naught. I naught equals opposite 3K over 3K plus 8K sum of 2 milli. That is 3 over 6 over 11 milliamp. And V naught equals 6 over 11 milli times 4K, 24 over 11 volts. Right, for the dependent, because we cannot calculate RTH. For RTH, we need to turn this off, but we cannot turn this off. And RTH is all about resistors. This is resistors. If it's not, so if we have something, we have voltage, and we want to find V naught using Thevenin, we can take this out and make this short circuit, and we're going to take this out. Now everything is a resistor. So these two are parallel. After you calculate that and the series, that's the RTH, right? However, we cannot turn this off, any dependent source. So basically, we cannot calculate RTH. That's why we have to find IN, so that RTH equals to VTH over IN. We good? 100%? Okay.